Excel solver and do that, but a large one we can use a software like R, which I have used. So this will force the probability. Once I know log of the odds, I can go to this. Now one problem, case problem, which I have taken only 30 sample size from a very good book, classic book written by Naresh Malhotra, Marketing Research, a latest book, where he talks about the brand loyalty, which is a 0-1 type, and 30 respondents have been divided into 2 equal parts. 15 are brand loyal, indicated by 1, and 15 are not brand loyal, indicated by 0. So we also measure the attitude, whether this brand loyal prediction of probability, is it related to the attitude towards the brand, attitude towards the product category, and attitude towards shopping on a scale of 1 to 7. 1 means unfavorable, 7 means favorable. In other words, the outcome of brand loyalty probability, which lies between 0 and 1, depends on the 3 input variables, namely the attitude toward the brand, attitude toward the category, product category, and attitude towards shopping on a scale of 1 to 7. 1 is unfavorable, 7 is favorable. We treat this as a interval scale, a continuous number, numbers are there. Now you have to use logistic regression and interpret the results and how brand loyalty is influenced by the 3 variables, which variable is more important, which variable is significant, which variable is not significant, and all that. So if I do first the ordinary least square, this is the data set, sorry for the small fonts, loyalty is 1, 1, 1 is coded, not loyal is 0, brand, product, shopping. I have just put simple names, this attitude towards the brand, I call it as a brand. So all are rated on a scale of 1 to 7. Okay, this is the picture. So the loyalty prediction, I need to base it on brand, product, and shopping. In other words, what is the relationship between loyalty and this? This is what I am trying to understand. If I use the regression, an Excel package or R, very simple regression anybody can do. Supposing I take this as the dependent variable y, and these are independent variables, brand, product, and shopping, and run the regression linear model, the ordinary least square regression, I get this predicted probability which I have highlighted. In this you will notice record number 4, 4th respondent, probability is 1.07. It cannot go outside. And another one, record 10, 1.01, record 15, 1.07, and so on and so forth. And on top of it, another tragedy has struck the output. Some places minus 0.29, minus 0.07, absurd to the power infinity, because 0 to 1 probability we are talking. So it is absurd to the power infinity. So this we cannot use. Why logistic regression? Because OLS will fail in predicting the probability. It has to be between 0 and 1. Will you accept? Sometimes in conversation we say, I am 200% certain. You can never be 200% certain. It's art of exaggeration. Only 100% you can be certain. So we are ignoring regression and we apply logistic regression, and the log model which I showed here, for example, what is this side? It is doesn't work, or yeah. Let me just show you this. This log model is what we are taking. The log of this is B0 plus B1 x1, B2 x2, B3 x3. Here there are 3. So let me go back to this here. The order in which logistic regression should be interpreted, I want to spend a few minutes on that. There are several books, packages are available, software packages are competing for statistical space, but no software package is equal to the subject statistics or model building. You will have to be aware of it. The order, some of the great works of Paul Green, if you see, there is a book, Paul Green, Analyzing Multivariate Data, a professor, distinguished professor who discovered along with Srinivasan the famous conjoint analysis. Conjoint analysis, the author is passed away a few years back, and Wharton Business School. A very beautiful book he has written, which is mathematical as well as practical, beautiful book. I have used some data sets from there, I will show you. The order in which is straight away we start summary A, B, C, Z test and all that. No. First of all, whether the logistic regression model on an overall basis is valid. That is the starting point, which is the log likelihood ratio test. You get the point? Log likelihood ratio test. Now, this log likelihood ratio test, the model I have used R, and it reports two things, model 1 and model 2. In a non-technical way, let me try to explain this. Model 2, which is appearing here, is loyalty tilt 1. That means I take only the intercept, I do not take any variable. Then I take the other input variables and compare this intercept. What is the improvement I have got? That is the basis, and the log likelihood for the model 1 is minus 11.7357, model 2 is about 20.79. The difference between the two multiplied by 2 is the chi-square test. In other words, you subtract 11 minus this, you will get 9 point something, multiplied by 2, a chi-square test. The p-value, statistics everybody knows, the p-value is the actual level of significance by which the null hypothesis is liable to be rejected. Now, the p-value is 0.000 something. If you take a level of significance of 5%, for example, normally when nothing is mentioned, we take that. At that level, it is highly significant, meaning that all the input variables are 0, all the independent slopes are 0, is rejected, the model is valid. Overall basis, there is a model which has some component, not that all are 0. So, the overall basis whether logistic regression model is valid, I have given the interpretation based on the chi-square test is overwhelmingly significant. That means on an overall basis, logistic regression model is valid. The second one, I use a pseudo R squared. The pseudo R squared, there are Mcfadden R squared, likelihood ratio R squared, Craig and Woolher, several people, but the Mcfadden R squared is the conservative R squared which is used. In regression, we use an R squared. The interpretation of R squared in logistic regression is not same as OLS. In OLS, what we do, if R squared is 0.6, we will say 60% of the variations or the changes in Y is captured by a set of independent variables. Here it is not the same meaning. The Mcfadden R squared 0.4356, which says 43.56% of the uncertainties encountered in the intercept model has been captured by the full model. In other words, if I use only the intercept model without any input variable but only the intercept, let us say there is some uncertainty which we call it as x. Out of that uncertainty, by adding all the variables, my uncertainty has been explained to the extent of 44%. So, 44% of the uncertainty of the intercept has been calibrated by the full model, that is Mcfadden R squared. Now, R squared will never be 1, R squared will never be 1 in regression type of a thing. In logistic regression, anything more than 0.3 to 0.4 is moderate, more than 0.4 is a good R squared. So, you should not, but you should see what is this R squared. The second one, first one is whether the model is valid on an overall basis, the second one is the R squared thing. Yes, you had a question?
Yes, about the previous slide.
Yeah. Yeah.
How do you determine that the p-value is at the 5% significance?
Now, that was said, when nothing is mentioned is a universal convention to take 5%, but here the p-value is the actual level of significance. Okay? The p-value is the actual level of significance. Now, alpha, which is the type 1 error in statistics, we take it as 5%, but let us say 1% you take. Now, what it shows is this is significant at 0.04% itself. So, it is overwhelmingly significant. You compare the p value with the desired alpha. This is the actual alpha. Whenever the actual alpha is smaller than the desired alpha, the null hypothesis is rejected and you conclude the logistic regression is valid. So, let me come back to that. A little bit of theory, I try to make it as simple as possible. So, this is Mcfadden R Square, which is similar to the OLS, but the interpretation is if I use only the intercept model, I have encountered some uncertainty. Out of that uncertainty, by using the full model of all variables, I am able to capture 44% of the uncertainty. This is the Mcfadden R Square. So, it is reasonably good. The next one is the individual coefficients. If you say on the overall basis the model is valid, let me look at brand, product and shopping. The individual basis, I look at again the Walls test or the Z test, and I say intercept of course is valid, but brand is the most significant one and product and shopping are not significant. In other words, we just draw an inference that only attitude towards the brand is overwhelmingly significant, explaining loyalty. So, attitude towards product and shopping is not significant. Then I am raising a question to all of you. In statistics, what we say is not significant means you do not get the license to omit those variables, they are not significant. In other words, does this imply